Welcome back. Now let us learn about logistic regression. It has been most talked about for almost a good number of years, and most of the people they talk it in a very simple language, and this is also there in the industry for I think last 30 to 40 years, and it is one of the most popular as well. So let us start why it is popular. See, in case of in our life as well, the many work which we do, we have to say either yes or no. So it means if you could be either good or bad, fraud or genuine, normal or anomaly. You could be employee of the company, yes or not. You are a student of the university, yes or not. You are present today in your class, yes or not. You have come to office, yes or not. You have violated any traffic rule, yes or not. There is nothing called in between. Although there are some state exist in between, but mostly it is either you are yes or no. That is why this logistic regression has been one of the most talked about this over here. And many people say that even the word regression is there in this term, but why do we learn in classification? Because classification, if you have seen the classification, we are learning with a multi-label. Here label number is 2. When the label number of 2 does not mean that it has become different from classification, and that is the idea behind that. It is the classification technique. Then why the word regression? Let me explain. See, how does this work? So whenever you try to find it out whether it is 1 or 0, internally it gets the probability. That probability of say 1 is say 0.7 and 0 say 0.3. So probability of 0.7 is higher, and that is why we say yes, it is 1. Okay. Now you think from the regression point of view. If this should have been the pure regression, and any score between 0 to 1, it will give say 0.7. That is a score only. So if you look at from the regression point of view, it is 0.7 is a score, and if you look at from the classification point of view, 0.7 is probability of becoming 1. That is why that score and probability, since both ranges between 0 to 1, it matches. Only that these are the two different ways to look at the same number. And I think that is why regression word is there in this one. And this is my understanding after reading the various research paper and all. But definitely this has been defined a little bit different from the different researcher. Okay. Few things you should know it, and again I'm just want to emphasize, not necessarily you will be doing all of things. All the modern algorithm can take care of everything whatever is there on this slide. You don't have to do anything on your own, but only from the learning point of view you should be aware of it. Okay. The first thing, the dependent variable should not be normally distributed. If you remember that this was one of the criteria when we started doing the regression, but here that is not there. And most of the old techniques or the classic techniques uses the OLS, ordinary least square, and here it uses the MLE. MLE is maximum likelihood estimate. Maximum likelihood estimate try to work on an objective, say minimizing the error. An error could be actual minus predicted. So basically MLE try to find it out the various set of parameters for which this error will be minimum. And I hope you recollect the residual analysis. And we had said that residual should be normally distributed, but it looks like here that is not that much required. Okay. See, again here that linear relationship may not be there between independent and dependent variable, but something they should be associated with a logit function. What is a logit? Again, I'm going to explain it over here, but again, just reiterating myself. See, logit function and all these things I'm just explaining just for your concept point of view, and if you are a researcher, it is useful for you. If you are a practitioner and data scientist, you know it, but you may not internally be knowing, because everything algorithm will take care of it, like conversion to logit version and then reverse transformation and so on. It will take care of everything. You don't have to worry about at all. Okay, so see, in case of we have the function like this, y is dependent and it is x is independent. So this is the function, most of the functions, and we know that we have to find it out the probability of between 0 to 1, and we know the probability will always be positive. So we can definitely write it like this one, e to the power this part. So whatever this part is there, p will be always some positive number. And we know that probability has to be less than 1. So if we divide this p by greater than the p itself, so how can we do it? This is the p we have defined in the equation p, and dividing the plus 1. It means whatever this number is, this 1 plus this piece will be always bigger than this part. So it means this p will be always less than 1. Once you combine all these three, then you will get p equal to this is the power, and this is also known as logit function. Okay, if you solve this one for y, you will get this equation. This is the equation using logistic regression. And here p by 1 by p is also odd ratio. What is the meaning of odd ratio? Odd ratio means here probability of happening, that is something happening, against not happening. This is the probability odd ratio. And again, these things just for your learning purpose, and everything will be done by the equation itself, algorithm itself. Okay, and should we take that, what should we take the probability if p is more than 50%, 60%, depending upon the situation? That I will explain you. Say, let's assume here, in case of fraud and genuine, the data you have, say around 90% normal people, genuine people, and around 10% is the fraud. So for you, it will be cutoff will be 0.9. It means any probability above 0.9 it will be fraud, and below 0.9 it will be the genuine. But from the fraud, if you see from the nature point of view, it is one of the very severe allegation. It's not that you can tell fraud to anyone. So if you want to be a bit more strict, then you can say, okay, even though my data say 0.9, but I will change it to say 0.97. So any probability above 0.97 will be fraud. So this will be more restricted. It means you will be getting almost actual fraud or near actual fraud people. Okay. So this is all about the logistic regression, and I hope you have understood. And if you have any questions, please write it on the discussion board. Thanks for watching it. See you in the next one.